Hello students, today we are going to see some more interesting and important questions from previous year questions, that is AIEEE, that is All India Engineering Entrance Examination. Come on, let us discuss the first question. The end of the product of the following reaction is, so propionic acid reacts with chlorine in the presence of red phosphorus. You are getting that product which is again reacts with alcoholic potash. What is the end of the product? Okay, now these both are important major naming reaction. The first one, Cl2 along with the red phosphorus, you know what is the naming reaction? It is called HVZ reaction. Okay, so this is also known as Hell Volhard and Zelensky, full name Zelensky. So that is HVZ. Come on, now let us check how that reaction takes place. Here propionic acid, no, CH3 CH2 COOH in the presence of Cl2, red phosphorus, red P. Okay, now you will get that all this is actually alpha hydrogen. See, this is alpha and this is beta, right? This is a functional group. So in that functional group next to carbon, it is alpha carbon. In that hydrogen, it is called alpha hydrogen. So alpha hydrogen, which is replaced by one chlorine atom. So what is the product you will be getting? You know, so here CH3 CHCl COOH, right? So another hydrogen which is combined with another one more Cl, so you will get HCl. That is common, right? Okay, so this is alpha chloropropionic acid. Okay, now this alpha chloropropionic acid reacts with alcoholic KOH. The second one, it is alcoholic KOH. Okay, so this is what it is, alpha chloropropionic acid, propionic acid, right? Okay, now here the second point, this is the first one. Now the second one, here what do we write that? Here CH3 CHCl, here COOH. So here alcoholic KOH. You know what is the speciality of alcoholic KOH? Aqueous KOH, alcoholic KOH. In this question, they are asking alcoholic KOH. So alcoholic KOH actually dehydrohalogenation. What do we call? Dehydrohalogenation, and also known as important naming reaction. I told, no. So that is actually Sides of reaction. Another one more name we can say, this is beta elimination reaction, right? So beta elimination reaction. See, what are the important points you just remember for only alcoholic KOH? Right now here, just I wanted to mention here CH2 instead of CH3, instead of that CH2, one hydrogen I just mentioned here, and CH here Cl, and here COOH. Right now what happened here? CH3 only, no, one hydrogen I just bring it out. Okay, now here these both are connected. So this is alpha carbon, this is beta carbon, right? So from beta carbon, one hydrogen which is coming out and combined with this alpha chlorine, you will get what it is, HCl. It relieves that HCl, right? So it relieves that HCl. That is what beta elimination and dehydrohalogenation. So halogen will be removed. So this bond which is going to attach over here. So what is the answer you will be getting? So you will get that answer, CH2 double bond CH COOH. So this is the final product you will be getting. I hope you got the clarity. CH2 double bond CH COOH. You know where do you get the double bond? This hydrogen which is removed, right? So automatically this bond which is going to connect over here. So you will get the double bond CH2 double bond CH COOH. So this is the end of the product. So this is alpha beta elimination. This is called beta, right? So beta elimination, also known as dehydrohalogenation, one point, sides of rule the other point, and beta elimination is the third point, right? I hope you got the clarity about these two reaction, right? Now which is the correct option? Option C, right? CH2 double bond CH COOH. This is what we have gone through, that point, CH2 double bond CH COOH. This is what we got it. So this is the correct option and answer. I hope you got the clarity. Come on, let's go to the next question. Picric acid. Picric acid, it is very famous and very simple question also. Picric acid, it is nothing. 2,4,6 trinitrophenol phenol only, we can say picric acid. Here OH, here NO2, and here NO2, and here NO2. Okay, so this is called picric acid. Okay, now picric acid, here there is usually acid group, means a COOH group will be attached. In this point, there is no COOH. That means, how do we say it is an acid? See, from here, actually OH group, in that hydrogen which is ready to donate H plus ion. So that is what mainly we are saying. It is a very strong acid due to proton donor. So the first point, it is proton donor, right? So the second point, see here, nitro group 1, 2, 3 nitro group which is attached to that benzene. Generally, that is actually what it is, electron withdrawing group, right? Electron withdrawing group, actually very strong acidic point. Okay, so that is a minus I effect, right? And the next one, it is a stable conjugate base. Third point, it is a stable conjugate base. So these are the three main points makes this 2,4,6 trinitrophenol very strong acid. So what is the name of this? 2,4,6. That is a phenol first, no? So 1, 2, 3, 4, 5, 6. So that is what 2,4,6 trinitrophenol. Right. I hope you got the clarity. Now, which is the correct option? Option C is the correct option, 2,4,6 trinitrophenol. And it is very simple. And 2,4,6 trinitrotoluene, it is an explosive. So instead of OH, you will get a CH3. So that is toluene, 2,4,6 trinitrotoluene. That is explosive material. This is 2,4,6 trinitrophenol. It is a picric acid. I hope you got the clarity and the difference. Come on, let's go to the next question. The next question, as we observe, in the anion HCOO minus, the two carbon oxygen bonds are found to be equal length. What is the reason? See, actually here HC double bond O, here O minus. So this is actually, for this only I have written. So here transfer of electron takes place. So naturally this will go there. So that means you will get another structure, what it is, H, see, single bond O minus charge, and here you will get double bond O. Right now, this is one resonating structure. This is another one resonating structure. You know what is it? Resonating structure commonly HC, here O minus, and here O minus. Right. So both are having what it is, equal. See, both the side it is like sharing each other, like both the side it is equal bond length. See, carbon oxygen bonds are found to be equal. They are asking whether it is equal or not. So two resonating structure is available. Two resonating structure. So naturally bond length, it is actually equal. Bond length equal. Right. Okay. Now, so the anion HCOO minus has two resonating structure. 100% it is correct. Related bond length only they are asking. Right now, come on, next option. Let us check. The anion is obtained by removal of proton from the acid molecule. This is 100% correct. Actually, anion is obtained. How do we get that anion? HCOOH. This is formic acid. So, the removal of proton. So, this is plus and this is minus. So, the proton, removal of proton only we are getting this anion. Yes, exactly. But which is related? What they are asking? Carbon oxygen bonds are found to be equal length. So, bond length, carbon and oxygen bond length only they are asking. So, they are not asking about that how that anion is obtained, that they are not asking. So this is not related answer. So which is the related answer? This is only. So this will answer will be wrong. But actually truth it is anion. How do we find, how do we form that anion? It is actually removal of proton. Yes, it's correct only, but it is not related to this answer, right? Now third one, electronic orbitals of carbon atoms are hybridized. Of course, 100% electronic orbitals of carbon atoms are hybridized. And the next one, so but it is not related to this answer, right? Next one, carbon C double bond O bond is weaker than C single bond O. See, of course, this is pi bond, but whereas this is sigma bond. Sigma bond, it is more stronger than pi bond, right? So naturally it is true, but which is not related to this. They are asking what it is, bond length of oxygen and carbon. Bond length, whether it is equal or not. Yes, it is 100% equal. Why? Because it is two resonating structure it is there. So both are actually bringing over here. This also it goes and that also it goes. So whichever way it is going easily, that is actually equal. So it is giving and taking policy. Say you are giving and I'm taking, like, so this is actually what it is, equal bond length. Like ozone also you will get that same idea. And yeah, ozone you will get O3 you will get that same idea here, bond length will be equal, right? Carbonate ion also you will get that kind of nature. I hope you got the clarity why A is correct, other three are wrong. Yes, come on, let's go to the next question. The next question here, CH2 double bond CH COOH is reduced with the lithium aluminum hydride. The compound obtained is, here, see, lithium aluminum hydride, it is a reduction reaction, right? So here CH2 double bond CH COOH combined with lithium aluminum hydride, 100% reduction reaction. Lithium aluminum hydride, you know what is the purpose we are using for reduction? It is converted here in this point acid group into alcohol. That's all. It will not affect the C double bond C. That's all. Lithium aluminum hydride is used for what purpose? Acid group to alcohol group. Okay, so this is acid, and you are converting to alcohol, but it should not affect the C double bond C. That means it will not affect the alkene part, right? So that means CH2 double bond CH, it will be safeguard. And here CH2OH. That's all. The COOH has converted to what it is? CH2OH. That's all. So acid group converted to alcohol, which we are using for what it is? Lithium aluminum hydride. Hope you got the clarity. So which is the correct option? Option CH2 D. CH2 double bond CH CH2OH. Here double bond it will be there, but here there is no double bond. Here actually what it is, same acid group it is there. No, reduction means acid group converted to alcohol. Then aldehyde, no, it is not possible. No, what is the main idea? We are using lithium aluminum hydride, acid converted to alcohol, and it should not affect the double bond. Right, hope you got the clarity. Please remember these tricks and all, so that it will be easy for you to remember during examination time. Come on, let's go to the next question. The next question, the general formula CnH2nO2 could be for open chain. So this is diol, dialdehydes, diketones, carboxylic acid. See here actually, yeah, this point here, concept based question. Now I just mentioned everything so that it will be useful for all that. Now which is the correct option? Finally we can decide. Right now the first one, diols. Diols, what is the formula? You know, CnH2n plus 2, right? And O2. So this is another one. So this is hydroxyl group. Hydroxyl. Hydroxyl groups. That is what it is. Here, diols. Diols is like hydroxyl group. That is what diols. Vicinal diol, geminal diol we are telling, right? So this is hydroxyl group. Diol means it's a hydroxyl group. CnH2n plus 2 and O2. So this is diol. Then dialdehyde. So how do we observe dialdehyde? Here, dialdehyde. Dialdehyde. So this is CnH2n minus 2 and O2. So this is CHO group, right? So this is aldehyde. Aldehyde, I just mentioned CHO because diketone also it's available. This is carbonyl compound in that way. So this is diketone. So diketone, what is it? CnH2n minus 2 and O2. So this is carbonyl compound, generally C double bond O. Here also the same. Okay, now next one. Both are similar, same, right? Because it's a carbonyl compound, right? Now carboxylic acid, mainly we are coming here. So carboxylic acid. So carboxylic acid, what is it formula? CnH2nO2. So this is what? Carboxylic acid. So I hope you got the clarity. Carboxylic acid only they are asking that question. So carboxylic acid, what is it? Here in this point, here Cn, here CnH2nO2. So this is only the correct option. Hope you got the clarity. CnH2nO2, it's a carboxylic acid. Other than that, diol, dialdehydes, diketones, you got that another point. How do we identify other groups? So which is the correct option you can provide? Which is the correct option? Option D is the correct option. CnH2nO2, this is completely based on dicarboxylic acid. Whereas diols, I have given hydroxyl group, aldehydes and ketones, both are same I have given, right? I hope you got the clarity. Come on, let's go to the next question. Rate of reaction or C double bond O Z, right? And combined with the nucleophile it gives R C double bond O nucleophile plus Z minus. See, Z minus they mentioned very clearly. So that means Z actually it's a very good leaving group, right? Very good leaving group. Right. So that means, so what is that Z they are asking? Fastest. So due to that fastest, I mean, due to that leaving group only, it goes very fast. So R, C, double bond O, here Z. So nucleophile, which is attack over here means, so this is attacks over here. So naturally this releases. So here what you will get it? R C double bond O here Z instead of that nucleophile will be attaching because carbon is actually it is what it is positive charge, so that is what here negative charge which is going to attack over here, whereas Z it is a minus charge, so it releases, so that is what Z minus. So in that, which is that Z OCOCH3, no, this will not be possible. And next one OCH2CH3, this also will not be possible because here also it is there positive negative, so which is the strong leaving group, like for example electronegative group, it is having a strong leaving group, and here amine it is not that much, it is actually basic point. Cl minus electron withdrawing group only. So electron withdrawing group usually what it is electronegative group, we will say it is a strong leaving group. So in that way saying chlorine only is the exact example for this question. So here Cl might be, so automatically Cl minus it releases. I hope you got the clarity why we are not selecting all this. We have selected amine, this amine NH2, it is actually base, and here O, here minus charge, and here C2H5, here plus charge, right? We cannot bring over here because strong leaving group they are asking. So strong leaving group means exactly it should be electron withdrawing group, that is more electronegative point, it has to be present, right? So then only we are giving that option. Already we have seen this question same way we have seen in first topic, that is general organic chemistry also we have gone through PYQ. See, some questions are related points it will come because organic chemistry it's common for all, so anywhere everywhere you can find the question mixed up. And come on, let's go to the next question. The next question, consider the acidity of carboxylic acid. Here PHCOOH, orthonitrobenzoic acid, para-nitrobenzoic acid, meta-nitrobenzoic acid. Which of the following order is correct? Right, come on. Let us check. Already I have given the same idea in one of that acidic strength. I have given another one more video, a complete idea about all the acid groups I have given in that another video. I'll put it in that description box. Now you just check this one. This is benzoic acid. I just draw the structure for you to understand. Here acidic strength I have actually put it one video, so please check it in the description box. I will put it. So this is benzoic acid. Here ortho nitro benzoic acid, right? So this is benzoic acid, this is ortho nitro benzoic acid, right? And this is second one, third one, it is para nitrobenzoic acid. So this is benzoic acid. Generally here you will acidic strength, there are so many questions are available, and like mind blowing questions all will be available. Right now here what it is, NO2 para nitrobenzoic acid, and the next one meta nitrobenzoic acid, right? Meta nitrobenzoic acid, here NO2. Right. Now, here, two main things I would like to tell related to this point. Here, acidity of carboxylic acid. Acidity of carboxylic acid. Carboxylic acid. See, acidity of carboxylic acid determined by the stability of the conjugate base. So, it is stability of conjugate base. Right. Okay. Now, stability of conjugate base enhanced by that electron withdrawing group. So, this is decided by whom? It is electron withdrawing group through minus I effect and a resonating structure. So, this what it is, electron withdrawing group, that is minus I effect, and resonating structure, that is actually what to say, more stable conjugate base, the strength of the acid, the stronger of the acid, decided by most stable conjugate base. That is what I just mentioned. Right now, these are the two main points decided: electron withdrawing group and resonating structure. Even last question also we have seen that formic acid in that formate ion, right? So in that we mentioned. Right now, here generally I'll give that concept for you, a simple trick for you. Generally, which is that the strongest, ortho is stronger than para, then meta. So this is the idea I just give. Ortho, it is very strong, stronger acid than para is another stronger. The last least one meta. Okay, I will give then that finally benzoic acid will be coming, right? Okay, now I'll give that reason for each thing. Then we can decide. From this only you will get that idea what it is. From this only you will get that idea which is that strong and weak. From this is that only you will get that idea, right? So from here only you will get that idea, but still I would like to give the reason for you to remember. See, first and foremost, ortho effect. Ortho effect actually, it is substituted benzoic acid stronger than meta and para, right? So it is a substituted, of course, position due to that ortho effect, which involves the combination of steric effect, right? So ortho effect, it is nothing, steric effect, right? Okay, so this is most acidic. Which is most acidic? Ortho nitrobenzoic acid, it is most acidic due to what it is? Due to steric effect. Near it is neighbor only, next to that point only it is available. See, from here only, so steric effect, it will be possible to get that. So this will be more stronger, most acidic, most acidic. Why it's most acidic? Due to ortho effect. You know what is it? Ortho effect, that is nothing, steric effect only. Ortho effect, adjacent carbon is having such kind of things. That is what it's most acidic. Then next one, it is para. Why para? It is because it exerts both minus I and minus M. So here para nitrobenzoic acid, the second most what it is strong, it is para nitrobenzoic acid. Okay, so why? Because here minus I effect also it's available, minus M also it's available. So here para nitro benzoic acid is weaker than ortho nitrobenzoic acid, but minus M is still very strong. Okay, minus M, that is this minus M nitro group exerts only that minus I. So resonating effect is not transmitted to that carboxylate group. Right, now the last one, what it is? Paranitro, I mean, this already right. So this is actually this point, it is orthonitrobenzoic acid is stronger than paranitrobenzoic acid. That is what I just given that idea what it is. Ortho, para, meta, and finally you are getting what it is, benzoic acid. So which is the correct option? This is 1, and this is 2, this is 3, and this is 4. Here meta nitrobenzoic acid, so this is actually meta position, this is para position, again I have drawn. So this is actually meta position, right here it has to come nitro group, meta position. So this is right, so this is only para and this is meta. Now how do we bring the order here and this point? So here you will get that point of um 2. This is actually orthonitrobenzoic acid. This is 2 again, 2 in what 2, right? So this is 2 is the first one, and 3 is the second one, and metanitrobenzoic acid. Ortho, para, meta. So this is actually 4, and the last one 1. So benzoic acid is the last one. That is what I just mentioned very clearly here only. So this is a simple trick. Ortho, so 2, it's greater than. Next, 3, it's greater than 4, it's greater than 1. So this is actually 2, 3, 4, 1, right? So ortho para meta benzoic acid. So 2, 3, 4, 1. Option A only as the answer is available. Yes, option A is the correct option. 2, 3, 4, 1. Hope you got the clarity. Acidity of carboxylic acid decided by whom? It is actually conjugate base and electron withdrawing group. So these resonating structures, these points we can mention here. I hope you got the clarity. Come on, let's go to the next question. The next question, on mixing of ethyl acetate with aqueous sodium chloride, the composition of the resultant solution. See here what it is, on mixing of ethyl acetate. So here CH3, C double bond O, OC2H5, ethyl acetate combined with what it is, aqueous sodium chloride, NaCl, aqueous sodium chloride. Here this is aqueous. So what is the product they are asking? See here actually, NaCl aqueous, it is a neutral, right? Neutral. And here what it is, acid plus alcohol. So this is actually acid, acetic acid, alcohol combined together only, it is called ester, right? So acid and again neutral, how it will be possible to react? Actually here no reaction only, right? Here no reaction, same as it is you will be getting. So here what it is, no reaction. So, which is the correct option? Option D is the correct option. CH3COO, C2H5 plus NaCl. NaCl aqueous, they mentioned, no, it is a, what it is? Neutral. So, neutral will not react, again the same, right? Hope you got the clarity why option D, no reaction. Yeah, come on. Let us go to the next question. The next question, which one of the following is reduced with zinc and hydrochloric acid to give the corresponding hydrocarbon? See, here zinc, they mentioned very clearly here what it is, zinc with HCl, right? So zinc actually, zinc amalgam with HCl. So zinc amalgam with HCl, we are getting that hydrocarbon, means 100% this is actually Clemenson's reduction, right? Okay, now here Clemenson's reduction, which is a ketone, actually ketone or aldehyde, carbonyl group, aldehyde. So that only you can get what it is, hydrocarbon, right? Now here in this point, I just bring that idea for you. Here what it is, CH3, CH2, C double bond O, CH3, right? The first one butanone, but2-one, right? The second one acetic acid, CH3, C double bond O, OH, acetic acid. This is A and this is B and this is C, acetamide, CH3, C double bond O, NH2. Why I mentioned all this? No, these are also what it is, carbonyl group only, C double bond O, it is there, but still we are giving that point of aldehydes and ketones, right? More importance, right? Ester, ethyl acetate, just now we have seen, no, last question, CH3, C double bond O, O, C2H5. So everywhere you can find that carbonyl compound, yes, of course, but they are asking that reagent what it is, zinc with HCl, that is Clemenson's reduction. Clemenson's reduction, this is used for ketone or aldehyde converted into what it is, hydrocarbon. So in that point, ketone only, it is a main point we can decide. So which is the correct option? Option A, we can bring it. So butane 2-one only is the correct option. Hope you got the clarity why we are giving importance. Other point also, acetamide also carbonyl compound, ester also carbonyl compound, acetic acid also carbonyl compound is available. But still we are giving the priority over here because Clemenson's reduction, it is ketone conversion into aldehyde. That is what we are mentioning. Hope you got the clarity about this question. Come on, let's go to the next question. Next one, which of the following is reduced with the zinc and hydrochloric acid to give that corresponding hydrocarbon? The same question only repeated. This is ninth question and this is 10th question. See, repeatedly they are asking. This is also 2004, right? Ethyl acetate, acetic acid, acetamide, and butanone, but2-one. The same only. Option D. I hope you know that clarity about this question. Why we are giving that? This is actually, this is Clemenson's Zaten bar Hg. That is zinc amalgam along with HCl. This is Clemenson's reduction. Clemenson's reduction. Right. So Clemenson's reduction. So this is ketone or aldehyde converted to, this is convert reduction, no, this is converted into hydrocarbon, right? Hope you got the clarity. Yeah, now other than that, even this point also it is having what it is, carbon common, but it is not compulsorily it is bringing that hydrocarbon, because some of the points we can bring it that point of weak comparatively aldehydes and ketones, and these reactions undergoes with that ketone aldehyde undergoes with that Clemenson's reduction, whereas here ethyl acetate, acetic acid, acetamide do not go under these kind of reaction. Hope you got the clarity now, which is the correct option. And the same question which is repeated, that means how much it is important, you please note down. Yeah, thank you for watching. Thanks for your great support. And aldehydes and ketones are very, very important for upcoming exams. So please go through thoroughly all the PYQs. And thank you for watching.